Yeah, so my name is James. I'm currently leading the developer experience function at a company called TwelveLabs. For context, we a Series A startup with 2 offices, one's in San Francisco, where I'm based up, and we have another office in Seoul, South Korea as well. Our company is building a video intelligence platform, and that's why the title of this talk is called Video Intelligence. It's called Agentic, and really I want to spend this session to talk about this big shift happening currently in video AI, which is how we, moving beyond just like static video models, doing more interesting agentic workflow, right? So let's start with a pretty simple observation, which is the fact that video is everywhere, right? Video is how we learn, how we teach, and how we remember. But it's also one of the most underutilized form of data in the current modern stack, right? With the improvement in technologies to film, stream, and store video, it is a matter of fact that video could explode in every industry, taking up 80 to 90% of the world's entire data by the end of 2025. However, the infrastructure that we have built to interact with that video data is quite brittle. It's built for tagging frames, not for understanding stories. This is quite a bottleneck, and it's holding us back. Right? Most video tools in the market today rely on predefined labels or rudimentary image-text matching. You can get a very simple and generic concept like a cat, a dog, a person, a ball, right? And therefore, you cannot search or detect activities, things moving through time in a more holistic manner. And you cannot really understanding the scene understanding, like the stories behind what happening in every single frame. Most current solution actually generate metadata and tags based on the video frames. The issue is these tags and metadata is is shallow, right? It's very slow and inconsistent, right? There's been other effort that actually using large language model to understand video. Basically, some of the existing LLM model in the market have this ability to do image captioning, right? And the way they did it is they actually break the data into frames, and they use that image understanding capabilities to try to get a very simple knowledge about the frames. Picking at a few frames per second is actually not very scalable at all, because it could be useless, especially for things that are real-time video understanding, right? So my main message over the past few slides is that we've been trying to squeeze video to the format of text or images, and it just doesn't fit, right? So at TwelveLabs, as a company, we build models. We build video understanding models that can see and reason about video like no other AI solution in the market. We actually benchmark our solution, and it actually sets state-of-the-art standard for new era video data interaction. And to be more concise, the first model is called Marengo. This is a video embedding model that can transform text, audio, image, and video into numerical representation called vector embeddings, right? So if you work in AI, you've read any papers or follow what's going on with the frontier model, you probably heard of vector embeddings before. Essentially, these vector embeddings enable you to perform very sophisticated information retrieval, and now you can perform very powerful cross-model search, right, across text, audio, image, and video. And the powerful capabilities of any-to-any retrieval like this can transform a lot of different applications, right? Everything ranging from content discovery to video recording system, hybrid search, and anomaly detection will change for the better, right? And then we also have a second model called Pegasus. This is a video language model that understands your video content and can actually generate accurate description and analysis about the video. We build an API, and then using that API, you can use that model to answer questions, generate caption, creative outputs, and provide very detailed analysis, time-to-time understanding, spatial understanding about any objects, activity, action within the video itself. Simply, you can describe what you need via natural language. You can get marketing suggestions, high-impact captions, or even summaries of the video instantly. Right. So these are what I mean by video understanding model and how to go beyond just looking at frames or metadata. Stepping back into the language model landscape a little bit, right? What we've seen over the past like 1.5 years is that we have made a huge leap going from static model to interactive agents, right? This kind of agentic system can understand your goals, plan multi-step actions, use different tools, even reflect on mistakes, right? And I put here on a slide a couple of the most well-known agent frameworks in the market. Everything ranging from LangGraph to Leda to the SPI, OpenAI Agent SDK, even AWS have a new solution called Agent Core that got recently released, just a couple of weeks ago. These frameworks have become critical infrastructure. They're providing different structured approach for building reliable agents, right? And these frameworks, essentially, they all implement some of the essential capabilities of building agents, from planning to tool integration, memory management, as well as self-reflection. Additionally, the field of agents can also identify some of several key design patterns that drive the success. These patterns include task decomposition, which means breaking goals into manageable steps; recursive reasoning, which means applying logic to intermediate results; tool augmentation, which means expanding capabilities through API; and human-in-the-loop collaboration, which means incorporating user feedback. And these patterns work across different domains, therefore establishing core principles for effective agent design. And so one of the key insights that my team has been thinking about, like, if these design patterns for efficient, agentic workflows works very well for language, then it probably can work for video too, if we do it right. And so, we've been basically exploring the academic literature around video agents for quite a while now. The big distinction is that video is more than language, right? Video is temporal, spatial, and multimodal. It unfolds over time. It carries sound, motion, and narrative structure. A true video agent needs to reason across multiple timescales, from frames to scenes to entire stories. It needs to integrate vision, audio, and language, and it needs to do it efficiently at scale. And therefore, generic LLM agents applied to video do not cut it. We need agents that are actually native to video. List here on a slide a couple of the most interesting research paper over the past years or so that basically try to build like this video native agent. On the left side is a paper called Agent. They pioneer a solution to these challenges through a very innovative architecture that combines multimodal RAG with divide conquer reasoning approach. On the top right of the screen is a work from Stanford called Video Agent, long-form video understanding, which LLM as agent. It explores efficient search and aggregation of relevant information from lengthy video. And then on the bottom right of the screen is another work called Labi, and this is actually focused on video editing that combines the reasoning capabilities of LLM with very specific with video-specific action, right? So overall, like the literature in this field has been evolving quite a lot, and I think like at TwelveLabs, we're super excited to just apply some of the learnings that we get from the researchers in the field. And we've been basically prototyping this video agent framework called Jockey, which actually open source, at some point last summer, and we're currently like having this product in private alpha. But essentially, it's a framework designed from the ground up, right? Under the hood, Jockey orchestrates two foundation models. It uses Marengo for multimodal video search, and it uses Pegasus, which is our video language model, for reasoning and generation. And altogether, they are coordinated by what we call a planner worker reflective architecture that run entirely on LangGraph. It essentially let the Jockey agent break down high-level tasks, code the right tools, and maintain context through long, complex workflow. So our idea here is that can we build a video assistant that can listen, think, and execute at much speed, right? And the source code of this project is actually open source, at least the earlier version of it. So even just that, would love to you guys take a look and think about how we design. Right? So for the next few slides, because it's more of an engineering or like technical audience, I want to go over some of the thoughtful design that we incorporate when we try to build out this agent framework. Right. One thing that I want to really emphasize that creating an effective video agent presents some of the unique engineering challenges that are very specific to video manipulation that extend beyond typical LLM applications. The most notable challenge involves performance optimization in video processing pipeline, particularly for complex operations like clip extraction and clip combination. So the approach that we have taken is twofold. First, designing a synchronous processing pipeline using function dispatchers that handle discrete steps in the workflow independently. This way, we have a modular architecture, and we can break down each step of the agentic workflow, and then we can do logging, chasing, observability, basically manage each function in a very modular and nimble approach, right? And secondly, we expose this processing stage to the end user through a transparent thinking state that is shown in the UI. And this transparency isn't just about status update. It builds essential trust by revealing how the agent reached its conclusion, showing which processing component are being leveraged at each moment. So this is a screenshot of one of the earliest version of Jockey that we built, right? So because we focus on video, we take a lot of inspiration from other video interfaces. And what we notice is that the traditional video interfaces have typically forced the end user to choose between either text-based search that ignore visual context or video players with very minimal interactive capabilities, right? So when we design Jockey, we try to reimagine the relationship between text and video to a fundamentally multimodal interface that combines both the conversational interaction with video native elements, and therefore treating both the text modalities and video modalities as first-class citizens rather than forcing one to accommodate the other, right? So the interface that I show here on the screen, I demonstrate that approach, right? So we have a conversation area on the left side that can capture the user intent through natural language. We have a visual thinking display. We have a visual thinking display that reviews the agent reasoning process. And then we have a video gallery on the right side of the screen that presents results with relevant context, like timestamp and description. So just zooming in a little bit, what makes this approach very powerful is this bidirectional flow of information, right, between text and visual element. So if we take a look on the left side, right, it shows how Jockey actually display agent thinking step alongside timestamp video segment, and therefore helping users understand not just what content was found, but why it was selected. And our rationale behind it is that it creates a virtuous cycle where each modality enhances the other. Language provides precision in specifying intent, while visual elements provide richness and context that can be inefficient to communicate textually. So that's one on the first point, right? The second point is that video content is inherently temporal and dense with information, making it very difficult to scan, browse, or compare in the way users scan with text. So Jockey interface actually substantially reduce cognitive load, allowing users to maintain context when working with multiple videos simultaneously. So the screenshot here on the right, you can see how the user asked, that can you please summarize this video in an emotional tone, and we actually display all the the video associated with the text description, so that you can reference what video that you're working with, and therefore it allows you to quickly capture the content of the video without having to go back and see back and forth, right? Yeah. There's actually a question on the chat which I will go into by the end of the presentation. Yeah. So let me show you what is unlocked, right? One of our customers is called MLRC, which stands for the Toronto Maple Leaf Sport Entertainment. And this is the entertainment arm behind the Toronto Raptors, the Toronto Maple Leafs, some of the biggest sport entity in Toronto. So they use this video agent application to build a personalized highlight reels in 9 minutes. And it's actually going down from 16 hours, right? So they go from 16 hours to 9 minutes. So that is 98% efficiency in highlight creation. So now they're generating dozens and dozens of personalized highlight edits of sport content for their fans in real time. And this is what happens when you bring agentic intelligence into production. So the road ahead, this is what we're just getting started, right? There's a lot of things that we can been thinking about to improve the quality and the engineering process of a video agentic system. And our roadmap is actually built around 3 core principles. First principle is called flow-aware trajectories, which means that can the video agent anticipate your next move and prepare assets in advance. In practice, this means Jockey can predict which clip might be needed next during the highlight generation process, suggest appropriate transition based on content, and even pre-assemble rough cuts that can align with the user's editing pattern. And this is like very powerful capabilities, especially for our user persona who are video editors who want to make like content, video content on an iterative manner. Right. The second principle is called contextual meta learning. It means that the agent should be able to learn the user preference and then adapt different style and pacing over time, right? And this can help create virtuous cycles where the agent become more valuable over time. It can remember different requirement that is specific to the project and adapt into feedback. And you can probably see like a lot of this happening currently with coding agents or generally like deep research agent, for example. They have these very powerful memories capabilities that can remember like your previous history, for example. And we try to bring it the same idea here, but to the context of video understanding. And the last principle is essentially multimodal orchestration, where you can combine videos, audio, text, and image all together into a seamless workflow, right? You can like upload audios, upload images, and then from there you can get very powerful text summaries, or even like image generation, video content generation that essentially combine all these modalities together in a meaningful results, right? And the reason we think this is a very important principle is because the world is obviously moving, at least the AI, foundation model ecosystem is going towards multimodal, and people have enable very complex operation, right? In the context of video understanding, this operation can mean like retrieving different scenes based on thematic relevance, analyzing narrative flows across multiple clips, or identifying emotionally resonant sequences automatically, right? So you need to rely both the audio within the video, the visual frames in the video, as well as on-screen text, etc., to be able to really return like really good results, right? Yeah, so that's the end of my talk. If you're a developer building with video, would love to hear from you. The link that I put here on the slide is actually a QR code that will take you to a Typeform that will enable you to register interest to try Jockey. The product is actually currently in private alpha, and we have a small program where we try to find design partners that we can work with, who can who love to tinker with new products, agentic workflow and multimodal workflows, and then they can provide us with relevant insights and feedback so that we can make the product come out open beta and hopefully GA in the future. So yeah, this is the link, and would love to hear from you if you're interested in trying it out. Perfect. So now I will go back to the Q&A, and I think there's a couple of questions that we'll spend some time over the next maybe 10 minutes or so to answer this question. All right, so I start with the first one. Have you noticed users trusting video agents more or less than text-based ones? What shaped that trust? I could say first thing is that video agent is relatively a new concept, right? If you actually doing research on, you do a quick search on like Google or Perplexity, it's very rarely that you're going to see like a video agent terms in production. So my point is not even like a popular term yet. So people actually haven't interact with I can say a true video agent, publicly, yet. I could say that my hunch is actually more trustworthy because when you interact with a video, you can actually visually see what's going on, right? You can visually, hey, if it's written a description about this frame, you can actually go back and watch the entire video and verify, right? This is actually a correct description. It doesn't hallucinate, right? So I think like the fact that you can like verify your text output based on the video content in a very simple manner, I think that will help. That makes like the trust level increase, right? Versus when you only work with text, then it's very dense. It's hard to like go back and see whether it's correct or not, right? The second question here is from Ruben. When you're working with long video timelines and complex agent workflow, how do you keep things from getting too heavy on compute? Any tricks you have seen that helps team keep inference fast and efficient? Yeah, so this question is more on the infrastructure and inference side of things, right? The first thing that comes to my mind is you want to use a very strong reasoning model that can orchestrate the agentic workflow, right? So currently, Jockey, as I mentioned, is actually built on top of LangGraph, and LangGraph is a very powerful orchestration layer that allows us to route user query and orchestrate the plan, come up with the plan, and then return the results. So we really trust the LangChain team on the orchestration layer, and we're actually currently using an LLM, essentially GPT-4 right now for the planning, the query planning, and then the two core, right? And the good thing is it works pretty well for now. When it can accept the user input and know how to route to the right tools to use, right? And it's very reliable at the moment. Therefore, we don't have to call. You don't have to call you have to interact with the agent multiple times because it tends to get a pretty good output at the first try. So my recommendation here is just try to use a very good reasoning model and a very good orchestration layer. Obviously, since there's been a lot of activities happening currently in the reasoning ecosystem, whether it's Claude, right, or whether it's Gemini, or whether it's open source model from DeepSeek and Kimi, etc. So I definitely recommend you to try it out, and especially if it's open source model, then you can try it out, and it definitely costs less than third party API, right? So definitely try it out, some of these open source models, see the output, evaluate how many times it get the right answer, right? All of this will help you minimize your number of requests, which therefore minimize your spending on inference compute. Yeah. The third question here is from Alyssa. Have you seen any useful patterns for incorporating user feedback into agent refinements? What works beyond just thumbs up and thumbs down? Yeah, this is a really good question. I think I have a lot of thoughts on this. We actually take quite a good amount of inspiration from some of the I don't know if you see some of the browser agents currently happening in the ecosystem, right? I think OpenAI is starting out with the operator product, and then there's our companies like Adapt, which is also building action what is that action foundation models. They got acquired by Amazon afterwards. There's Manos as well. Manos AI company from China. I think they recently moved out, and then they also have a very cool demo on how you can interact with the screen, right, and then get information back. So I think a very powerful way to incorporate user feedback is actually capture the action on a screen, right? Is there a way for you to what I call session replay, which means that can be record the actual user session as they interact with the agents, right? And then we can visually, qualitatively see how they chat with the agents, right? Now we have an actual record of what they're doing, what frustrating to them, at what step that they got stuck and churn, right? What step that they really like and they continue, right? How do they type the search query, right? All of these are qualitative element that a very simple thumbs up, thumbs down not going to be able to capture. So this is something that I think we try to build out for the Jockey product as well, which is an ability to capture the user session and then use that as even information context, right, for the agent to take into account and become better for the next chat history, right, chat session with the agent itself, right. And this going back to one of my my point about contextual meta learning, right? In this slide right here, when first time it might fail, but over time it will improve. And the reason we can improve is because it can capture the user session and learn, adapt the preferences over time. Yep. And then one final question on the chat from Aaron. Do your models can capture implicit scene understanding like tone or intent, or is it still mostly surface level content? Yeah, so my answer is yes. So our models can definitely capture very implicit scene understanding. Going back to the screen real quick. Yeah, so we have two models. as I explained, the Marengo model and the Pegasus model, and this model are multimodal, right? So when we train the Marengo model, we take in the video as input data, and then we actually like capture all the audio in the video, all the visual information in the video, all the text in the video, right? And these are like different modalities. And then our video embedding model actually like, have separate encoders within the architecture to capture these elements. Like for example, like there's a auto encoder, right, that can capture all the conversation or music sound in the video. There's a visual encoder that capture like objects, activities. There's a temporal encoder that capture like motions, right, within the video. And then we essentially just like, can wrap all these multi-vector embeddings into the same latent space. And therefore, when you perform retrieval or like analysis, you actually interact with this latent space, which is super holistic, and it's already captured like all the modalities within the video itself. And then you can search for like, someone crying, right? You can like ask the Pegasus model, hey, what is the intention? What is the basis from an interview, right? And it will be able to like, grab those contexts and then return an answer that actually, reflect what's going on in the scene, right? So these are like all things that we back into the training data, and as we back into the how we design the architecture to get the most out of the video content, and also is how we implicitly make the video language model have a better reasoning and agentic capabilities. Hope that answers your question. Okay, so there's a new question here. When something sensitive or problematic happening in a video, like a policy violation or violent moment, how does your system stay aware of that over time? Are there any techniques you use to keep that kind of context across scenes? Yeah. So yes. So in this scenario, like scene understanding will be extremely important, right? Security, public safety is actually one of the main vertical use cases for TwelveLabs, by the way. And in this scenario, our customers actually use our model to detect, right, when there's something bad happening, like a violent moment, right, or like a policy violation, etc. So the way they did that is that they actually upload the entire live stream footage, right, whether it's from a security camera, whether it's on a house monitoring, or whether it's the body cam from the police, and they run through our model and essentially like processing for every few seconds, a couple of frames to see whether this violent moment happened, right? If it not, most of the time it will happen, right? But when it happened, it will actually being detected by our Marengo model, which is really good for search, right? So we can search and detect that moment, and it would actually trigger the front end so that the person can take action. So that is from a like pipeline engineering design. From a modeling point of view, an action that is sensitive or problematic happening in your video is a trigger event that will have a lot of that have higher frequency, higher I would say higher amount of information, right, in the video. And the way, if you like familiar with transformer and like the transformer architecture, there's a very specific component called attention mechanism, right, that can essentially in layman terms can detect or like pay more attention to aspect of the data that have more information than the other, right? The same idea here for video transformer, which is like kind of the main backbone architecture behind some TwelveLabs model. When there's a scene or moment that have high amount of information, it will pay more attention to that scene, and that's how you can keep context about that scene throughout the time. Yeah, hope that answers your question, both from an engineering point of view and then the modeling point of view. All right, I think that's top of the hour, and stop sharing my screen. Thanks to everyone for listening to my talk and ask very engaging and meaningful question.